Let's jump right into this explainer because it's going to completely change how you view so-called natural disasters. For the longest time, we've basically been conditioned to just accept that when the earth shakes or rivers flood, massive human suffering is just part of the deal. We see destruction on the news and think, well, there was absolutely nothing anyone could have done. But today, we're diving into the hard data. We're going to break down the science of risk management and highlight a really crucial distinction between a natural hazard and a human disaster. By the end of this, you'll see exactly why experts around the globe are telling us to literally drop the phrase natural disaster from our vocabulary altogether. To get started, I want you to imagine this terrifying scenario. It's the dead of night, exactly 2:17 a.m. Suddenly, a violent earthquake completely rocks a coastal community. The power grid instantly fails, plunging the entire town into total darkness. Panicked residents are jolted out of a deep sleep, rushing out of their violently shaking homes and into the pitch-black streets. It is just pure, disorienting chaos. Minutes later, tsunami warnings start ringing out across the dark coast. But tragically, this quickly becomes known as the day the sirens failed. And here is where the real disaster unfolds. You see, this unsuspecting fishing community, they don't actually understand what those specific siren patterns mean. They have no safe evacuation plan in place. They have absolutely no idea where the designated elevated safe zones even are. So by sunrise, what started as a purely natural geological event has resulted in devastating casualties, mass displacement, and severe emotional trauma. Now, there's a stark difference between two concepts that we honestly mix up all the time. The hazard is the earthquake itself. It's just the shifting of tectonic plates, a completely natural, totally unavoidable phenomenon. But the disaster is the preventable human loss, the destroyed buildings, the shattered lives. The earthquake didn't mandate those casualties. The lack of preparation did. Disasters literally only happen when natural hazards crash into highly vulnerable communities. So the whole thing boils down to a really crucial formula. This is how scientists probabilistically calculate disaster risk. First, you take the hazard, say a typhoon or an earthquake. You multiply that by exposure, which just means who or what is physically sitting in the path of that hazard. Then you multiply it by vulnerability, how susceptible those people and buildings are to actual harm. Finally, you take that whole top line and divide it by capacity, which is the community's overall ability to protect themselves, respond, and recover. If your vulnerability is sky high and your capacity is super low, your disaster risk absolutely skyrockets. But mathematically speaking, if you can just boost your capacity, you drastically shrink that overall risk, even if the hazard itself remains incredibly severe. Section 1. The Philippine Risk Profile. Highly vulnerable. Let's head over to the Philippines for a moment to see how this all builds into one of the most high-stakes risk profiles in the entire world. When we run the numbers using that exact risk formula for this specific geography, the results are staggering. Looking at the Statista Risk Index for the country, on a scale of 0 to 10, with 10 being the absolute highest risk possible, tropical cyclones sit at a massive 9.4, tsunamis are at 6.7, and earthquakes are at 6.1. The Philippines sits squarely on the Pacific Ring of Fire and right smack in the middle of the global typhoon belt. So, natural hazards? They're basically a guarantee here. It's a geographic reality that plays out year after year. But remember, the hazards alone aren't the whole story, right? Why is the actual risk so exceptionally high? Well, it comes down to these specific multipliers. You have physical vulnerability, like poorly built housing crammed into dense areas. Social vulnerability, meaning poverty or unequal access to health services and education. Then there's economic vulnerability, where families just don't have a financial safety net to recover if they lose everything. Add in environmental degradation, like rapid deforestation making catastrophic landslides way more likely during heavy rains, and institutional vulnerability, which means weak urban planning or poor communication from the top down. These are the human-made factors that turn a passing storm into a full-blown catastrophe. Section 2. The DRRM shift. Reactive to proactive. To stop these frequent hazards from turning into disasters, our global approach had to fundamentally change. We realized we couldn't just keep waiting for things to break and then handing out tents and bottled water after the fact. So over the last few decades, our whole paradigm evolved. Back in 1989, the UN launched a decade of disaster reduction awareness just to get the conversation started. But the big shifts happened later. The 2005 Hyoga framework officially prioritized proactive risk management, and the 2015 Sendai framework shifted the entire global focus to holistic, integrated resilience across all levels of society. And the Philippines mirrored this beautifully in 2010 with Republic Act 10121. This landmark law officially pivoted the country from reactive relief, just cleaning up the mess, to proactive disaster risk reduction. This proactive mindset gives us 4 continuous cyclical steps of disaster risk reduction and management, or DRRM. Step 1 is prevention and mitigation. This means building massive protective dams, reinforcing structures, or enforcing strict zoning laws to blunt the physical impact. Step 2 is preparedness, running regular community drills, stockpiling resources, and setting up reliable early warning systems. Step 3 is response. That's the critical search, rescue, and relief operations when the event actually hits. And finally, step 4 is recovery. But not just rebuilding infrastructure so it's significantly safer than before, a concept heavily promoted as building back better. The golden rule here: acting decisively during those first 2 steps, well before disaster strikes, saves the absolute most lives. Now, while we are shifting paradigms to be way more proactive, we still have to deeply respect massive threats like geological hazards. We're talking about unfavorable ground conditions and geological processes that result in unanticipated, substantial damage. Because unlike some human-induced issues, geological hazards simply cannot be prevented. We can't stop tectonic plates from shifting beneath our feet. We face everything, from sudden releases of crust strain that cause massive earthquakes, to volcanic eruptions spewing molten lava, to massive underwater disturbances generating tsunamis that can wipe out entire coastlines. We also face severe landslides, triggered when gravity finally overcomes Earth's strength on a saturated slope, and sinkholes, where the ground just terrifyingly collapses. The impacts are sweeping. They cause immediate, heartbreaking loss of life, but they also bring severe long-term economic damage and lingering psychosocial trauma, like chronic anxiety, that can haunt communities for years. We can't stop them, so we can only mitigate their devastating impacts through brilliant planning. Section 3: Technology and Early Warning Systems. This is where modern heroes enter the story. Spearheaded by dedicated scientific organizations like DAST PVOLCS in the Philippines, we're seeing some incredible technological warning systems. If we can't stop the Earth from moving, we absolutely have to know exactly when and how it's going to happen. Using a highly advanced, multi-level approach, remote sensing and local sensors are doing incredible work every single day. We're talking about tools like ultrasonic tide gauges that detect sudden sea level changes, giving us precious, life-saving minutes before a tsunami hits. The Volcan platform allows for near real-time visual monitoring of subtle volcanic unrest. And the Dynaslope project? It's truly fascinating. It deploys deep sensor networks in high-risk upland communities to continuously measure rainfall, deep ground deformation, and even soil moisture. They can actually predict a landslide before the slope catastrophically fails. Best of all, this tech isn't locked away in some high-security lab. It's right in the palm of your hand. The Honda app uses artificial intelligence to consolidate hazard maps and crucial location-based safety info. Hazard Hunter PH lets anyone run a detailed assessment on their own property to see if they're sitting on a hidden fault line or right in a historic landslide zone. And the Volcano PH Info app delivers early warning alerts directly to citizens' mobile phones. This tech doesn't just inform people, it completely empowers them. Section 4: Building Resilient Communities, Barangay Assessments. Because as our opening story proved, all the technology in the world, all those advanced apps, and every single siren is absolutely useless if the community doesn't understand them or know exactly what to do when they sound. That's why local communities, like Barangas in the Philippines, have to conduct their own thorough vulnerability assessments. They need to honestly audit and score their own exposure. They rate indicators as strong, moderate, or weak by asking the hard questions. Are we near a flood-prone river? Are our houses poorly built? Are there elderly residents who will need extra help evacuating? By honestly auditing their evacuation routes, the clarity of their warning systems, and their baseline health access, they pinpoint their weakest links before the hazard ever arrives. Because if you have informal housing next to a river and your evacuation route is rated weak, you have incredibly high vulnerability that needs immediate addressing. So, what makes a community truly resilient? When we finally recognize that disasters are not just unavoidable acts of nature, but actual fixable failures of human preparedness and social equity, we're forced to look in the mirror. We know the hazards are coming, we have the technology to see them, and we have the mathematical formulas to completely understand our risk. So the ultimate question we have to ask ourselves is this: when the sirens sound in your neighborhood, is your community truly ready to act?